Hi class, in this lecture I want to do an introduction to exponential and logarithmic equations. Now, basically what I'm going to do is I'm going to walk you through a bunch of different examples for how to solve exponential and log equations. And I want you to know that the methods that I show are not exhaustive, like they're not the only way you can solve this. And it's going to take a lot of practice because every equation is just a little bit different. But this will help get you a good introduction to it and some approaches to solving. Okay, so let's start with exponential equations. So an exponential equation is one in which the variable occurs in the exponent, obviously. So some exponential equations can be solved using the fact that exponential functions are one-to-one. What that means, if you have a to the x is equal to a to the y, notice how the bases are the same, base A, base A. If the bases are the same, you can cancel them out and just have the exponents must be equal. Okay, so that x is equal to y. All right, so also the following guidelines describe the process for solving exponential equations. All right, first what you want to do is you want to isolate the exponential expression on one side of the equation. When you do that, if you have an exponent, the way you can help to get rid of it is you can take the log of each side, then use the law of logarithms to bring down the exponent. That was law 3 that we learned in a previous lecture. And then you want to solve for the variable. Okay, so let's try this one. Consider the exponential equation 3 raised to the x plus 2 power is equal to 7. First thing I want to do is I want to find the exact solution of the equation expressed in terms of logs. And then the second thing I want to do is we're going to use our calculator to find find an approximation to the solution to 6 decimal places. Okay, first off, what are we going to do? All right, so what we want to do is notice how to solve this. The variable is in the exponent here. So what we're going to do is we're going to take a log of each side. Okay, the reason we're going to do that is if you remember law 3 allows us to bring the exponent down. So what I'm going to do is I'm just going to take the log. So when you ever see log by itself, remember that's log base 10. So I'm going to have now log of 3 raised to the x plus 2 power is equal to log base 7. Okay, you can do that because you're still maintaining equality. If you're taking the log of one side of the equation, you just do it to the other. And then what you're going to do is you're going to take this exponent and bring it down in front like this. So, okay. Next thing you're going to do is you're going to take this log 3 and divide it over to the other side because you want to get the x by itself. Remember, log 7 and log 3 are just numbers, okay? Then to get the x by itself, you just subtract 2. So the exact solution to this equation, the exact value that solves it is log 7 divided by log 3 minus 2. You can use your calculator to find this now, and then you'll end up seeing that a decimal approximation x is roughly equal to 0.228756. All right, let's try this one here, okay? You're going to see it's a little bit different approach, okay? So I have e to the 2x minus e to the x minus 6. So the first thing you're going to do is you're going to look at it and it kind of looks like a trinomial maybe, right? But here we have e to the x, so it's not like an x, not like a polynomial, but it's still's got 3 terms. So this 2x here, what you're going to realize is that this is x to the second power here, or e to the x squared. So now you're going to factor this. You're looking for 2 numbers that multiply to -6 and sum to -1. Okay, so that's -3 and 2. So this, imagine if this was x and this was x instead of e to the x. It would factor as x minus 3x plus 2, but instead it's just e to the x. Okay, so now I have this times this is equal to 0. So either using our zero product property, either this has to equal 0, the first factor, or the second factor must equal to 0. So when solving, we get the following. E to the x is equal to 3, and e to the x is equal to -2. First off, e to the x can never be a negative number, okay? So this cancels, this will not be a solution. So solving this, what you'll do is you'll take the natural log of each side. So if you remember our rules, the natural log of e to the x is just x. So natural log to this side, you've got to take it to the natural log of the other side. So one solution is x is equal to the natural log of 3. All right, but as I said, the equation e to the x equal -2 has no solution because e to the x is greater than 0 for all x. So thus x is equal to the natural log of 3, And that's the only solution, and it's approximately 1.0986. All right, let's do some examples now doing log equations. Okay. Excuse me. A logarithmic equation is one in which a logarithm of a variable occurs. Okay. So some logarithmic equations can be solved by using the fact that logarithmic functions are one-to-one. Excuse me. So if you have log base a of x is equal to log base a of y, log base a, then the insides of each of these functions, x and y, have to be equal. All right, however, some of these are not that easy, so the following guidelines describe the process for solving logarithmic equations. So the first thing you're going to do is you're going to isolate the logarithmic term on one side of the equation. So to do this, you might need to combine logs using our rules of logs. Then you're going to write the equation in exponential form. You're going to raise the base to each side of the equation. I'll do an example of that. And then you're going to solve for the variable. All right, so let's solve these. Natural log of x is equal to 8, and then log base 2 of 25 minus x is equal to 3. Okay, so first off, you're going to take this. This is in log form. You can solve this by just switching it to exponential form, right? Like the base e, so this is log base e of x is equal to 8. So another way of solving this is just saying, let me just change this to exponential form. So x is equal to the base, and this is the exponent, so x has to be equal to e to the 8th power. That's one way to solve it. Another way to solve it is to raise each side to the base here. So remember, looking at our rules, e raised to the natural log of x is just x. So if I take e and raise this side to it, I have to do it on the other side. So you end up just getting the same thing. So it works that way too. All right, let's try this one. So the first thing I want to do here is take this and write it in exponential form, right? So take this log and put it in exponential form, right? 2 to the 3rd power, so the base to the exponent is equal to this, 25 minus x. Well, what you're going to do is 2 cubed is 8. Switching these around a little bit, you end up getting x is equal to 25 minus 8, or you end up getting x is equal to 17. So that's one way to solve it. Okay, the other way to do this would be to raise both sides, have this be 2 raised to log base 2 power of 25 minus x, those would cancel, and 2 to the 3rd, you get this. All right, I know this was a quick introduction to this topic, but practice with these, and you'll see a pattern emerge for how to solve these. And as always, if there's any questions, let me know.